Everyone, we're going to look at number 6 in section 2.3. This is using the basic limit laws. We're going to evaluate the limit using those basic limit laws. And this limit here, which is the limit as x approaches c of x to any power, they've got a fractional power here because powers could be fractional, but the limit as x approaches c of x to any power is c to that power. There are some restrictions depending on c, especially if q is an even number, like, if this was 1/2, we understand that's the square root. And obviously, if c were some negative number, the limit would not exist because we'd be taking the square root of a negative number. So, I mean, this is making some assumption here, but we won't have to worry about it in this problem or the others. Just we should be fine with that. And then limit as x approaches c of any constant k is k. Okay, so just here's the limit actually that I want you to find. And then what are the basic limit laws? Well, there's several of them. The ones that are going to apply in this one are the limit of a product of two functions equals the product of the limit, provided both of these limits exist. The second one is the limit of the sum of two functions is the sum of their limits, again, provided these two limits exist. Again, if these limits do not exist, we cannot make this jump in general. Number 3, the limit as x approaches c of any constant times a function is just the constant times that limit, again, provided this limit exists. And then number 4, the limit as x approaches c of x is just c, right? So these were the basic limit laws. This was an application really of that. It basically, this is really this, because if p over q is equal to 1, x to the first power, we really have that. So I'm kind of being redundant there. That's that same limit. Okay, so I'm going to evaluate this limit. And the first thing I'm going to do is use number 1. I have the limit of a product of two functions, right? So basically this is my, my function f of x, and this is my function g of x that I'm mentioning up here. And so it's the limit of f of x times the limit of g of x. Okay, and then I'm going to make use of number 2, because here I'm taking the limit as x goes to 1/2 of 10x plus 1. So that's the limit as x approaches 1/2 of 10x plus the limit as x goes to 1/2 of 1. So that's using this rule here. And this is the difference. Same thing if this was instead of plus, if this was minus, we just put a minus here. So the limit as x approaches 1/2 of 18x minus 1 is the limit as x approaches 1/2 of 18x minus the limit as x approaches 1/2 of 1. Okay, and then finally, I'll use number 3, constant multiples. Basically here in this one, I could take this 10, which is a constant multiple of x, and pull it out right in front, and it's 10 times the limit as x approaches 1/2 of x. Same thing here, I can pull that 18 out, and I get the limit as x approaches 1/2 of just x. Well, now each of these limits we can evaluate, because what's the limit as x approaches 1/2 of x? Well, it's just 1/2, and that's from this number 4. Okay, or from this, really same thing. And then the limit as x approaches 1/2 of 1 is 1, right? Because 1 is a constant. That's using this constant rule here, right? The limit as x approaches c of any constant is just going to be that constant. And then he said same thing here. This limit is 1/2. This limit again is 1. And so we just need to evaluate this expression. And when I do all the math, I get 48. That is the limit. So again, this is not going to be the way we find limits all the time, so don't panic, but it's getting you to understand these limit laws, and they are contingent upon the fact that these resulting limits all do exist, right? That's important. As we proceed on, when we get to continuity and talk about that, then we'll be able to use direct substitution to evaluate a lot of these, which is basically using the limit laws where the resulting limits exist. And so that's what we are going to be headed toward. So hope this is helpful.